Continuing with our smoking ban example from the previous video and page in the notes, we want to include shaded and labeled graphs and so on. So what is the probability of obtaining X equals 548 or fewer adult Americans to support a ban on public smoking in a sample of 1009? All right, so you'll notice it asks specifically for a probability. It says find the probability. So that means that we're going to be looking for the area over here on the right because the area under the curve is a probability. And that means we need a p hat. Okay, well that's a little bit interesting because they didn't give us a p hat on this problem. They gave us an x. Oh, very sneaky. All right, so x is a whole number. That's 548 people. That's not a proportion, right? But our curve that we have invented here, our sampling distribution of the sampling distribution of sample proportions, excuse me, has percentages. It's decimals, right? So it doesn't make any sense to work with 548. Or does it? Okay, so you have to remember a couple things. So 548 is x, but p hat is x over n. Ah, very key. That's a formula on the first page of this section, right? All right, so let's make a note of that. So note, well, actually, let's make a couple notes here. Hold on. First thing I'm going to note is that's a whole number, not a percentage, right? But in this section, we need percentages. Whole number. I'm going to give it a frowny face. Right? It's not a percent, not a proportion, which is what we're working with in this section. Boo. But we can turn it into a proportion. P hat equals x over n. That's a formula we know, right? So p hat equals x over n, which is 548 divided by 1009. Well, now we're getting somewhere. And I can go find that value with Desmos. So 548 divided by 1009 is 0.5431 repeat. Blah, blah, blah. I mean, it repeats for a couple decimal places. So it's 0.543. All right. So that I can work with. That's a decimal. That's a proportion, right? This is proportion. Yay, smiley face, right? That we can work with. And that's exactly what we're going to do. We're going to find the probability of obtaining fewer. Notice it, by the way, it said fewer. So we're going to highlight that. Oops, I smudged that, sorry. Fewer than. So that means we're going to go less than, right? So fewer means less than. So we have a couple things to note in there. All right, so let me make this so we can see again, side-by-side stat crunch, because that'll just make things easier for us. Okay, so we still have the 0.58. That's still our mean. We still have 0.015538 as our standard deviation because it's the same problem, right? So those values haven't changed. Because we want fewer, we're going to go less than. And here's the lovely thing. You actually don't need the decimal. You can actually type the fraction. 548 divided by 1009. Click compute, and it will find the value for you. It's 0.008797. Nice, huh? So, all right, so let's shade that, and then let's label everything. So right over here, we've got a little tail. We knew this value was p hat was 548 over 1009. That was the part we knew. And so the probability that p hat, right, capital probability, and again, it uses the letter X in there because StatCrunch doesn't know anything, right? It doesn't know what you're working on. It doesn't know you're working with a proportion problem. So it's less than or equal to 548 over 1009. If you like, you could use the decimal. Either way, is approximately 0.0088. That's what we were looking for. And just to prove to you, we can put 0.543 in here. It's close. It's a little bit off. If I keep more decimal places, it'll be more accurate, right? So if you're going to do a decimal or use a decimal, then I would say keep more decimal places, not less. So maybe make it 5311 or something like that. if you're going to go that way. But you don't have to in StatCrunch. StatCrunch and actually the calculator as well. They'll both let you just enter the fraction. All right, moving on to letter F. Let's find the 65th percentile of the sample proportion of adult Americans from blah, blah, blah. Okay, so remember, never forget, percentile is always the percentage below you. Let me write it down. Always. So this is going to be a less than, right? It's already established. But it is the percentage. The percentage is given, right? So the percentage is given. It's 0.65. All right. Now, what does that do for us? Well, remember from our table, if you're looking to find p hat from the percentile, you know the percentile. It's the 65th percentile. You're going to do this, right? You're going to leave your mu and your standard error of p hat, but you're going to put that 0.65 over here in the area zone. So let me do that. So I'm going to put 0.65 over here. And I know I want it to be less than, so I'm going to click compute, and there we have it. All right, so let's shade. This area right here is 0.65. That's the part that was given. This is what we're looking for, right? What's that value? Sorry, my equal sign's a little high there. Sorry. Okay, so the probability that p hat is less than or equal to, and then I said I wanted 3 decimal places for p hat. So 0.586 is approximately 0.65. There we go. That's the answer. That's what we were looking for. All right, next one. So suppose you conduct your own poll of 1,009 random adult Americans. Would it be unusual to find that more than 61.1% or 61.2% of them, excuse me, support a ban on public smoking? Okay, unusual, remember, unusual is less than 5%. If I could spell it correctly, unusual. There we go. Okay, then also notice that it's talking about more than. See that? So that's telling us that we want to go, let me circle that. That's going to mean that we have to go with a greater than. Right? That's the thing with StatCrunch. You have to figure out which direction you're going. All right, so I'm going to put 0.612 in here, but I'm going to switch it to a greater than sign because I want to be more than. And then it found it for me. There it is, 0.0197. All right, let me write that out and let me shade it. So it's a little bitty tail over here. I know this was 0.612. That was the value I knew, and I was looking for that area right there. So the probability that p hat is greater than or equal to 0.612. Remember that for a continuous distribution, it actually doesn't matter the or equal to, because the line at 0.612 itself has no area. It has no probability. On a continuous distribution, the probability of any specific value is always 0. So it doesn't matter if you say greater than or greater than or equal to. It's all the same thing. All right, so 0.0197. Now, don't forget to answer the question. Would it be unusual? Yes. This result is unusual because the probability, which was 0.0197, is less than 0.05. Oh, I'm sorry, that's off screen. I can make that part go away now. We're done with StatCrunch right there. Okay, so now suppose it happens. Suppose you did conduct your own poll of 1,009 adult Americans, and you got a whole bunch of them that want to support a smoking ban, a ban on public smoking. So what could be some possible answers for why that's happening? So first off, maybe your poll wasn't as random as you thought it was. So maybe you had a biased sample. So your sample was not random. And, oh, I don't know. It included a ton of people that have lung problems, or included a bunch of people, whoops, a bunch of people, there we go, with lung issues. Who knows? All right, or you know, you included accidentally a whole bunch of people that were marching at a lung cancer prevention problem. You know, so who knows? It could be anything. All right. Then what's another option? Well, it could just be a fluke, right? Weird things do happen. It's an unusual probability, but it's not an impossible probability. So fluke. By random chance, it just happened. The p-hat was high. Here. Oops. Right, it just happened, I should say. Well, I'll just say it happened. That was bugging me. By random chance, it just happened. The probability of that fluke is what we found above. It's 0.0197. Notice that it's less than 0.05. That's why it's a fluke. I mean, it has to be kind of a rare thing, right? A fluke is a random event happening, something weird happening by random chance. You can even say, like, weirdly. You know, by random chance, it just happened. Okay, so that's another possibility. So either we didn't have a good sample to begin with, or, you know, we had a good sample, but it just happened. Weird things happen sometimes. Who knows? And then the third option will be that the parameter, there's only one in this section, was wrong. Now, what was that parameter? Well, let's go back a page. Everything we did in this entire problem was based on one number. I mean, at its heart. The only population value we knew was this value right here. That's our parameter. It's a value that's known about our population. Technically, the sample or the population size is as well, but we're not dealing with that. So that we didn't work with that. So the parameter we knew is 0.58. So that p, which was 0.58, is wrong. Maybe it was never right to begin with. Maybe it's changed over time. Maybe it was correct at one point, but has become wrong later. Who knows? Sorry, my 8 was bothering me, but watch, this is going to be worse. Oh, there we go. That's better. All right, I'm going to show how to do the problems above using the TI calculator. But if you're not using a TI calculator, you can skip ahead. All right, back to here with the TI calculator. So let's make that smaller. All right, the TI calculator is right here. So this is a probability question. Probability questions use normalcdf. So we're going to go to second distribution, normalcdf, and we want to tell it from -1e99, because that's the left-hand edge of what we're doing, all the way up to, and you actually can type as well, just like they did, 548 divided by 1009. You can type it like a fraction like that. And again, if you want to use the decimals just like them, you can do that as well, but you'll want to keep 5 decimal places to make this accurate. And then the mean was 0.58 and the standard error was 0.015538, so that's all good. And there you have it. Same answer as them. And again, if you want to do that problem but use the decimal, you would use 54311. And that would get you the same answer as well. You can see you start losing accuracy about the 5th or 6th decimal places. That's why I'm telling you to keep 5 decimal places up there. All right, the 65th percentile, that's a distribution, inverse norm. So you want to say 0.65 is your area, and then this was 0.58, and this was 0.015538. And again, as this has been the case in Chapter 8, we've been working with a left because it's a percentile, and that's the same on the old calculator as it is in the new. The old calculator just doesn't say left at the end. There we have it. Oh, I forgot to write this down, so let me go write these. So TI. And again, if you're not using a TI, just skip ahead. You don't need to watch any of this. It's normal CDF. So this is negative 1E99 to 548 over 1009, 0.58, 0.015538. That'll get you that answer. On this one, you use inverse norm. So 0.65, and then 0.58, 0.015538. If you're on an old calculator, that's where you stop. On a new calculator, you say left as well at the end. Like that. Last one, I got to kind of squeeze this in here. So if you're, here, I'll put it up here. If you're on a TI, it's going to be normal CDF again. And you're going to start at 0.612. So we're going to do normal CDF, 0.612. We're going to forever, so 1E99. And then 0.58, 0.015538. And see, you get the same answer. So 0.612, 1E99. Oops, I'm running out of space. 0.58, comma 0.015538.